Similar polygons are polygons with the same shape, but different size. Polygons are similar if corresponding angles are congruent. So the angles need to be equal. And then the corresponding sides, they're not going to be equal. They're going to be called proportional. The ratio of the corresponding sides is called the scale factor. So it could be 2 times bigger, a half times bigger. That's the scale factor. And if they're similar, then their perimeters are also going to be proportional. So moving down to this next problem here, what's the scale factor of ABC to DEF? So from ABC to the other triangle DEF, you could just take one of the sides. So let's say 8 matches up with 12. And you put 8 divided by 12 and simplify that to 2/3, and that's your scale factor. Notice how we did ABC first, and then 2 DEF on the bottom. Now if we go backwards, DEF to ABC, that would be the flipped. So 12 over 8, which is 3 over 2. And like I said, order matters. We'll skip over the perimeter and go to similarity statements. So a valid similarity statement must match the corresponding angles and the sides. Write a similarity statement for the triangle above. Looking at these triangles here, looks like we got triangle ABC, and the symbol for similarity is the little squiggle. And if I did ABC, I have to think about what matches up to A is D, what matches up to B, and what matches up to C, and the order does matter. Again, the symbol for similar is that little squiggle, kind of like the top of a congruent sign. Okay, next, you do number 1 here. We're going to list all the congruent angles and write a proportion that relates all the corresponding sides. So the angles, we would say angle, let's say maybe K, and then that would match up to angle M, because I see that K is in the middle and M is in the middle. Next up, angle J, that would be congruent maybe to angle, let's see, P, because you see that they're both in the front. And I'm doing the congruent signs because the angles are equal. And lastly, angle L would be congruent to angle N. Now to do the sides, let's say side JK, that would match up to PM. Notice how I'm going in order there. So it matches up to PM. And when I write that, I'm going to say that scale factor is the same when I divide them. And that scale factor is going to be equal to another fraction of the sides, let's say KL, over what matches up with KL, MN. And then lastly, I need JL, and that matches up with PN. Just to review, angles are congruent, sides are in scale factor proportion. Okay, moving on the next page. We're going to skip over this. This is very similar to an example that we just did. And now we are going to find side lengths with proportions. Looking at number 4. If the figures below are similar, with the scale factor of 2 to 3, find the value of x. They told me the scale factor is 2 to 3. So I'm going to write that as a fraction, 2 to 3. And when we solve for these similar figures, we're going to create what's called a proportion, which is two fractions, two ratios equal to each other. So I need a fraction on the other side. 2 to 3 is on the left side. Let's do maybe 42 over x on the right side. And it has to be 42 on top and x on the bottom, because this was in a 2 to 3 scale factor, and the order does matter. To solve, we're going to cross multiply. 2 times x is 2x. 3 times 42 is 126. And dividing by 2 gives us x to be 63. Again, we're making proportions. Let's go on to maybe number 6. Here, they didn't give us the scale factor, so they gave us all the other numbers, and we're going to use that in our proportion. Setting up our proportion, we need the equal sign with two fractions on each side. Next, we have to fill in some numbers. Say this x side is AB, and that's going to match up with the DF side, or the DE, I'm sorry, the DE side, which is 25. So x with 25. The next thing they gave me on the triangle is 28, and that's going to match up with, since that's BC, that's going to match up with EF, which is right here. So I do 28 on top, 20 on the bottom. It would be wrong if you switched up the order. Now cross multiply. X times 20 is 20x. 25 times 28 is 700. And dividing to get x to be 35. Let me know what questions you have so far. I believe there is one more page to look at. Okay. Next one we are going to do is, let's say, number 9. Because number 9, the triangles are a little weird. They're kind of switched over and crossed over each other. When that happens, we really have to pay attention to this similarity statement to see what sides match up. Okay, we're going to find the values of x and y. Let's start with x first. So x is right here. That is KL. And KL is going to match up with ML. Okay, let me write my first fraction. So x matched up with 14. And let's see what else I need. Let's try this side over here. 40, which is JK. Let me show you what that looks like. JK is right here. And that's going to match up with NM. NM is right here. Awesome, that works. And that would be 40 on top, 16 on the bottom. We cannot have a proportion that has an x and a y in it. We can only solve a proportion if there was only one variable. So we're solving for x first. Okay, cross multiplying. We get 16x equals 560. So x is going to be 35. My other proportion is going to have to do with the y's. So let's highlight the y's. We have ln. And that's going to match up with LJ on this side. Writing that fraction down, you could say 45 matched up with y. And the other one is going to be, let's do 40, and that's going to match up with 16. So I would write that as 40 on top, 16 on the bottom. Notice the order does matter. since I did 45 and then y, I have to do 40 and then 16 for the other fraction. Cross multiplying, we get 40y equals 720. So y is going to equal 18. Alrighty. One last problem for today. Let's look at number 12. Here we're given the two triangles are similar. We have a small triangle and then a bigger triangle. And they gave us some values. Let me go ahead and put those in there. BR is this whole thing, 4x plus 7. BG is 18. So this whole thing is 18. To do my proportion now, I'm going to set up my fractions, put my equal sign in between, and let's see what's related. Let's do the big triangle first. So the big triangle, this whole big side is 4x plus 7. That's the whole big side. And the smaller triangle that it matches up with is just right here, which is 12. Now I'm going to pick another side on the big triangle. Let's see if I'm given anything on the big triangle. I am. I'm given this large side right here on the big triangle is 18. Notice how I'm putting the big triangle on top again. And then I need to figure out if they gave me anything that matches up for the small triangle. They do, which is 8 right here. And I put that on the bottom. Now I'm going to cross multiply. And this may look a little different than what we've done before. When you cross multiply, we need to do 8 multiplied by 4x plus 7 and distribute. 12 times 18 is 216. Distributing gives us 32x plus 56. Continuing to solve, we get x to be 5. If you need to, please highlight and look at the similarity statement to check to see what sides are matched up. That's the only tricky part of today's lesson. The solving and the cross multiplying is Algebra 1. You should be able to do that. Have a great night, guys.